Good day, everyone. Our next topic is about the derivative of trigonometric function. So we know that based on its definition or the theorem of the derivatives of trigonometric function is the first one is the derivative of sine u with respect to x. This is equals to cosine u. Then we derive the angle or the derivative of u with respect to x. The second one is if our derivative, so the derivative of cosine u is, so this is already a derived theorem or formula for the derivatives of trigonometric function. So if you're going to ask how did this function or this formula or equation derive, or where did it came from, so there was a long method for them. So you're going to apply the delta x delta y. So just try to search for them in the internet. So I think it was there. So the derivative of cosine u, this is equals to negative sine u, and then the derivative of du with respect to x. Also, the derivative of tangent u, this is equals to the square of secant squared u du dx. And then if we are going to, so it's antiderivative, it's reciprocal, so the derivative of cosecant u, this is equals to negative cosecant u cotangent u, the derivative of u with respect to x. Okay, so just take note that their u is the same. The derivative of secant u, this is equals to secant u tangent u, the derivative of u with respect to x. Also, the derivative of uh, cotangent u, this is equals to the square of cosecant negative cosecant squared u, the derivative of u with respect to x. So these are the trigonometric functions formulas in order to derive, for example, that are involving trigonometric functions. So our first example, if we have our y is equals to 2 sine 3x, what we need to do is just use the substitution method. So we let u is equals to sine to 3x, and then we could rewrite our given y is equals to 2 sine u. Therefore, if we're going to find the derivative with respect to x, this is under the constant multiple rule, so we need to segregate or to export the 2. Then the derivative of sine u with respect to x, we could apply the first equation, which is equals to cosine u du dx. So this equals to cosine u du dx. Now let's try to check. We have no du dx, so we need to find the du dx. So let's derive the du dx first. The u. Let's derive the u with respect to x. So this is equals to positive 3. So after that, we try to substitute this one. So dy dx is equals to 2 cosine u is 3x, du dx is 3. So overall, our answer is 6 cosine 3x. Next example. What if we have y is equals to tangent 2x? So automatic, we let u is equals to 2x, and then we derive the du dx is equals to 2. So we could write our given equation y is equals to tangent u. And based on our observation, it falls under the tangent u is equals, so it falls under the third theorem or equation that we had, which wherein the derivative of tangent u is equals to the square of secant u, then times the du dx. So overall, our dy dx, or equals to the derivative of tangent u with respect to x, this is automatic equal to the square of secant u, derivative of u with respect to x. And then we know that our u is equal to 2x. So secant squared, our u is 2x, and then the u dx is positive 2. So we could be able to, so just take note that we cannot multiply the 2 in our angle. Instead, we try to use this one as our coefficient. So 2 secant squared 2x. So this is our answer. So our third example. So what if we have an example, our example number 3. So let's, our y is equals to um, sine x over 2 plus cosine x. So in this kind of equation, we could be able to use the substitution method, and we'll let u is equal to sine x, we'll let v is equal to 2 plus cosine x. At this point, we could be able to rewrite our equation y is equals to u times v. And we know that if we derive this one, this is equals to v du dx minus u dv dx divided by the square of our denominator. Also, if so our v is already equal to already present, and then also the u. So next is we need to find the du dx. Since our u is equal to sine x, so the derivative of our sine x with respect to x, this is equals to sine x is equation number in the derivative of trigonometric function. It is equals to cosine sine x. This is equals to cosine. So try to use this one here. Okay. So it's equals to cosine x, the derivative of dx with respect to x. Okay. So this, so we must stop there because we arrive with dx over dx. This is overall our derivative for our du dx is equals to cosine x. Also, let's find for the dv dx natin. So the derivative of our dv dx, or 2 plus cosine x with respect to x, our 2 will become 0 because the derivative of a constant is 0, and then the derivative of cosine x is equals to, let's use this one. So we could say that our derivative of cosine x is equals to negative sine x. Then the derivative of x with respect to x, dx, this is also equal to 1, so we must stop there. Overall, our dv with respect to x is equals to negative sine x. So let's now substitute in our equation that our dy dx is equals to v. Our v is equals to 2 plus cosine x, and then our du dx is cosine x, and then minus the u is sine x, dv dx is negative sine x, divided by the square of our v squared, which is 2 plus cosine x. So we need to, let's try to simplify this one. So our overall, our dy dx is equals to, this is 2, so let's try to apply distributive property in here. So 2 cosine x, so this is 2 cosine x plus cosine squared x minus or plus sine squared x, because negative times negative is already positive. So divided by 2 plus cosine x dy dx. So we know that in trigonometric identity, we know that cosine squared x plus sine squared x is equals to 1. So therefore, we can say that this is already equal to 1. So our answer is 2 cosine x divided by 2 plus cosine x. The square, this is the square pala. This is the square. So this is plus 1. Okay, overall, so since this is already equal to, so since this is already, the cosine squared x plus sine squared x is equals to 1, and then this is already equal to 1, and then our answer would be 2 cosine x plus 1 divided by the square of 2 plus cosine squared x. So this is our answer. In our fourth example, what if we have our y is equals to tangent raised to 3 2x. So at this point, we could be able to use the substitution method. So we know that this is also equal to tangent 2x raised to 3. Okay, so now we will let m is equals to tangent 2x, and then our n is equals to 3. So we could write our equation from y is equal to tangent raised to 3 2x. This is equals to m raised to n. And we know that the derivative of y with respect to x, wherein our y is equals to m raised to n, this is m raised to n minus 1, a derivative of m with respect to x. So since our m is equals to 2x, so to find the dm with respect to x, this is equals to at this point, let me dx, we could be able to, let's try to extract this one. So our m is equal to tangent 2x. So let's try to substitute again. Let natin u is equals to 2x. So ang mangyayari, our m will become equal to tangent u. And then if we derive our u with respect to x, this equals to positive 2, because we know that our dm with respect to dx, this is equals to equation number, the third equation, tangent, this is equals to secant squared u with respect to du dx. So dm with respect to dx is equals to secant squared. Our u is 2x, the du dx is 2. So overall, our dm with respect to dx is equals to 2 secant squared 2x. So now we could be able to substitute in our equation. Our dy dx is equals to, so let's go back, n is 3, m is tangent to x, 3 minus 1, this is 2, and then our dm dx is equals to secant 2 secant squared 2x. So at this point, our answer would be dy dx, our answer is equals to 6 tangent squared 2x and then secant squared 2x. So this is already our answer. Our example number 5, what if we have our y is equals to sine 2x and then secant x. So at this point, we could be able to let u is equals to sine 2x. Our v is equals to secant x. And then we can rewrite our equation, our given equation y is equals to u times v, and then if we are going to find the du with respect to x, this is under the product rule. This is u, the derivative of v with respect to x, plus v, the derivative of u with respect to x. So now, since our u is already given, v is also given, we need to find the dv dx and du dx. So by using our first Latin, which is u equals to sine 2x, and then our du dx, this is equals to the derivative of sine 2x, or this is equals to cosine, the derivative of let's try to use this one. So the derivative of sine u over x is equals to cosine u du dx. So we could say that that its derivative is equals to cosine 2x and then the derivative of 2x with respect to x. So based on the in here. So overall, we could say that our du with respect to x is equals to, since the derivative of 2x, so this is already 2x, this is 2, and then dx, the derivative of 2x with respect to x is equals to 2 dx, so this is already equal to 1. So therefore, we could say that our answer would be 2 cosine 2x. So to solve for the dv dx, we need to use the, so this is just the derivative of secant x is just equal to secant x tangent x, the derivative of x with respect to x. So we must stop there because we are under the dx dx. So at this point, just observe the difference that we tried to use the cosine 2x and then the derivative of the 2x because it falls under the equation that we must not stop in here because we already, the derivative of 2x, which is our derivative, is 2. But as you observe here, magkaiba sila kasi yung ang mangyari is the angle of our secant is only x. That is why we need to nag-stop tayo dito sa dx over dx. Kasi wala na tayong i-derive pa. So overall, we can say that we must stop at a certain point that our derivative is already equal to 1 because it was stated in the chain rule already. So dv dx natin is equals to secant x tangent x. Now this is the time that we need to substitute the value of u in here, the value of v in here, then the value of our du dx in here, and then our dv dx in here. So just simple as that. So du dx is equals to u is sine 2x, dv dx is secant x tangent x, plus our v is equals to secant x, and then our du dx is equals to 2 cosine x, 2 cosine 2x I mean. So overall, if we find our derivative with respect to x, this is equals to, so let's try to secant x, let's try to simplify, is equals to tangent x sine 2x plus 2 cosine 2x. So this is our answer. So I tried to segregate the secant x.